bundles or any specific tooling related to modularization that we use at Booking, because it differs from project to project, from the size of the project, the needs of the project. And also, I'll not give you any magic pill that you can just swallow and then wake up and then say, hey, my code is modularized. However, what I will talk about is why did we start thinking about modularization at Booking? What were the problems that led to this? What did we try before actually modularizing our code? And what were our learnings from those failed attempts that we tried to solve our problems with? What is modularization? How did we approach it? How can you probably approach it? Where are we now? And what are the shortcomings of it? So let's rewind back to early 2017. Devs at Booking started realizing that it was becoming very difficult to iterate on changes, even the smallest of them. Imagine changing a color or a margin or a padding. And a lot of developers started complaining of these slow build times. So I'm not exaggerating, to be honest, but our code base is huge. But still, a clean build took up to 12 minutes. Which we would have to do every time we would switch branches or rebase master, or if Android Studio isn't happy. So it's like, sync me please. So clean build. Incremental builds were almost up to about 2 minutes, which would be the case for any small Java change or an XML file change that you'd expect. But still, I mean, 2 minutes is a lot. And this was on one of the most powerful Macs available in the market back then. And we also realized that number of features was actually going directly proportional to the build time. So the more features we're going to add, it's going to keep on adding up, piling up, and then the build times would grow up. So a lot of devs started looking into the solutions for this problem. And the first attempt was Instant Run, because it was built into Android Studio, and Google, as the name suggests, it has to be instant. But what happened was it did not work for us. Because we had custom annotation processors that we relied upon for some stuff I cannot talk about. We didn't feel it was worth investing time moving that thing out of the project and then maybe giving Instant Run a try, because I have never heard personally Instant Run doing wonders for any project. So we tried another thing. It was breaking the build. Don't get confused. What I meant by breaking the build was by breaking the build into multiple variants, flavors as you could call them. So after some Gradle profiling, we found that most of the time was consumed by two major tasks. One was processing of resources, and the second was compilation of the code. And since we support over 40 different languages in our app, we had resources for all of them. And you can imagine if we change just one file, Gradle would go crazy and then have to process all the resources thinking that, hey, something changed here as well. So we blew a kiss to Gradle. How, you'd ask? We created a build config that would only use resources from the English version. And for drawables and other layouts and things, we would only use stuff from the XHDPI. Now, as a developer, when you're writing code, when you're seeing changes, you would only do it on one set of language. And once it's completely done, you'd probably mirror it for the RTL or any language that you think copies might not fit in, might overflow, things like that. But for a normal dev, I think this was amazing. And for those who did not get the reference for keys, it's keep it simple, silly. So it worked, but you know how devs are. We were able to reduce the build times by almost half for the incremental builds. However, the devs were still not satisfied. I mean, who wants to wait for 2 minutes just to see if the margin increased by 2 dps or not? Whereas a front-end dev sitting right next to you can just hit the refresh button, and then voila, he sees all the changes in a flash. Attempt number 3 was composite builds. So like you'd imagine, developers would go to any extent to make their lives easier. So we were trying really hard. We started looking into composite builds, which were a new thing by Gradle back then. And it looked promising in terms of build times. This is a setup that we had when we were trying composite builds. So the booking Android is the main module, the God module that you'd look at. And then we had some smaller modules or libraries, as we call them, called Assistant, some other libraries, Analytics, and whatever. And the booking Android would actually take in these libraries. And these libraries can in turn then depend on some common modules that we wanted to share across, like networking, localization, whatever. So how did it work? We would just take a library, add it as a compilation thing, and it would compile for us. So every time you would make a change, you just get the stuff from the cache. And composite builds would integrate all these libraries to the main project so that it's easier to debug and refactor, because you won't want to open multiple instances of Studio and stuff. And after successfully making the changes in your library, you would just go to the CI, deploy it, and then you would start using it normally. Excited to see the results of composite builds. Well, they were amazing, to be honest. So we were able to bring down the clean build time from 6 minutes to 3 minutes for some cases. For a Java code change for 2.5 minutes to about 30 seconds. That's a 77% decrease I'm talking about. And also the Java plus resource change, or maybe just a resource change, was close to that. However, it did not work for us. Now you'd be surprised that why it did not work. The reason was the results that you just saw are from the main app, from the giant God module. But what happened in lieu of that was the Gradle config time increased. And for any other library that we were building, the times were growing. A clean build time for each module increased by 30 seconds. We did not want to do that. An incremental build time for each module then increased by 10 seconds. Now imagine if we start splitting everything into libraries and then start building them, even though smaller libraries are now going to grow. And we would end up in the same mess. It's just that then we would have to, now we know modularization, but back then we did not know. So back then we would have to modularize everything. And hence we decided we would not go forward with this solution. So like I mentioned, attempt 4 was JRebel. So I'm not sure if a lot of you have heard about JRebel, but it is a third-party thing. And it was supposed to be a competitor of Instant Run. So what they would do is they would do hot code reloading, or hot swapping as they called. And you could almost instantly see changes in your app. So they would install an app on your phone inside which your app would run. So whenever you made some changes in Java or XML, it would know what diff it had to just inject at runtime, so it wouldn't have to build stuff for you. However, there was a problem with that. We got mixed feelings about it because of the humongous size of our project. It did not really work how we wanted it to. So there were a lot of cases when the app was loaded by the JRebel on an emulator and it just wouldn't run. So it was really hard to go from one screen to another, and we did not really know what to do. Hot reloads would fail randomly, so you would have to then do a clean build, and a clean build with JRebel was much higher than we would normally do. But the best part of JRebel was that you could start the app from anywhere. So if, let's say, you're anywhere down the funnel and you just want to change some text copy, color, whatever, if you hit refresh, you don't have to do all those actions again. It would just reload from there like you would see in a web browser. But again, it did not work, as I told you. So we stopped using it. And also, I think in January this year, they discontinued active development of this product. And we were like, we should not invest any more time making our tooling accommodate this change. Attempt 5 is modularization, something that you'll have been waiting for. So let's talk about it. What it is. It is a process of breaking down a monolith into very small chunks. You could imagine microservices. And then this concept dates back to 1960s, so it's not something very new that you're seeing that, oh, we're now starting to talk about modularization. It's a hype in the Android world. No. We've been doing it for long. It's just that we did it in different manners. How would you do it? So you would have one entry point for each module, one exit point for each module. So you can determine, like, how am I going to enter the module and how am I going to exit the module. And then you would establish navigation between screens or areas of screens. We call each screen a module. This also allows them to be tested independently, which we leveraged heavily. I'll show you in the slides coming ahead. So why should you modularize? For starters, it improves productivity by allowing faster development, quicker iterations, slower build times, and build times can be as low as 10 to 20 seconds for smaller modules. So if you had a big app where you would have to spend at least 2 minutes to see your change if you're doing an incremental change, for a smaller module, which is like one screen which you're trying to test, this would go down to 10 to 20 seconds. You can easily swap in, add, remove, whatever new features, because it gives you the ability to replace and introduce new modules very easily. It's just plug and play in your build.gradle file. It also helps you tackle your debt, so your code is more isolated. It opens the possibility of code reuse, because you can then abstract your code further down and then reuse it within the modules that live in the layers beneath. Minimize the maintenance costs. Of course, if you have code isolation, you just have to maintain that particular area. You can cover it with tests easily because there are less dependencies. Let's look at how the project is layered at Booking. So the current structure, we have 3 layers. So we call them presentation, app services, and core services. So anything that contains at least one full screen that you'd see on the app goes into the presentation layer. So booking go, booking process, any feature, search. App services are something that the presentation layer needs to either display the data or take some actions, something like that. So any logic that could be shared between them goes into this layer. You can imagine components like user-generated content, data models, common UI between the screens. And then core services is basically things that can be considered to be reused within other apps as well. So imagine networking, analytics, icon font, localization stuff. So if tomorrow we want to spin up a new app, we won't have to rewrite all those things to work with the infrastructure of Booking. We could just use these core services, plug it into that app. And this is how the overview of the module looks like. So we have some presentation modules, like I said, app services, core services, and foundation systems. Now, this is really interesting here because I'll show you what this would do if you're trying to build just one module now. And how can you also reuse your module? So imagine you have multiple screens, but you also want to show some stuff on the same stuff on different screens. So UGC here refers to user-generated content. So imagine on the search, you want to show the review scores, and then if somebody goes to a details page, you also want to show the reviews there. And ideally, all this is coupled within the UGC module that you want to share. So what you would do is you would make a presentation thing out of it and then also abstract it down for UGC components and data so that it can be split across multiple screens. What tools did we build to simplify the work? Nothing very fancy. So we had a create module.sh shell script file. It was just a helper script to create your new module, because if you create a new module project in Android Studio, you would have to add a lot of boilerplate yourself. This made sure that we already injected that, because we have our custom build.gradle setup that needs to go in through each of the modules. This script allowed us to do that. Find bugs, generate baseline. As the name suggests, we wanted to have find bugs in each module, and we also wanted to have the baselines set up there. This script helped us to do that. And we also use this dependency visualizer a lot to find out what's the dependency graph looking like and how do we want to move forward. Solving the funnel problem for developers. So this is one of the very interesting things that we think that we did. And this was actually a big problem. And like I said, with JRebel, we were able to get this thing solved. So what a funnel is and how it looks like in terms of booking is, imagine this is the whole app experience. So you go from search, search results, and then some other pages. And then at the end, you make a reservation, right? Imagine if you're working somewhere in the middle. Every time you have to make a change, the app restarts. You go in, you have to make a search. Then you need to select a property. Then you need to go to that page, go to that room, and then whatever. However, what we did was app start tests. So what they are, we leveraged these things. So you just deep link into a module and inject real or mocked data that you can have to start your screen for different use cases. And then you'd also start the test once the screen is ready, and then just tell the test to sleep for a day. And you can do this on your device or on the emulator. Now, once the test goes into the sleep mode, you have the app to yourself, and you can now start playing with this thing. Now, how does it look like? It's something like this. So you have a test. It's saying launch results in the Booking.Go module. So you initialize something with fake bookings, whatever. You start the results screen, and then you say sleep days 1. So as soon as sleep days 1 comes in, the test goes into the sleep mode, and now you can just use that screen and do whatever you want to do with it. What this does is it only builds the dependencies that it needs. So it will skip everything that your module does not need and only build what it needs. So you can remove a lot of chunk out from that build process by just using the app start test. And how would it typically look like? This is an example. So this is the Booking.Go app start test. It has 11. You can start a screen from the first one. You can either go to a results screen, go straight to the booking summary. You could test with real or fake mock data. And in all the tests, if you see, we have the sleep thing there at the very end. What this allows developers to do is, if they want to get very down in the funnel and then just change that, they would run that test, do all their changes, test them, and then just quit the test. The app quits. This is the example thing. So when you make a booking in Booking.Go, you would see this thing at the very end. And in order to do this, you would have to go like select a car, then choose your preferences, fill in some information, and then go here. This will prevent you from doing that. You can inject everything, just test your changes, and you're done with it. Payments is another example. So again, you would be starting the payments activity with no saved credit cards, and you just inject whatever you need there. You sleep, you do that. You can also do some like espresso things with this. So you can even test them without having to actually run the app and manually going into and doing everything. This is the payments example setup. Again, this screen is very down in the funnel. So it's probably close to reservation. So you have at least 5 screens, and then imagine the number of steps that you have to take every time you come there. And if I were to talk about the things that happen with the payments module, so the changes in the module would now take only 25 seconds with a normal start. And with the test, it only takes about 12 seconds. That's 50% reduction in what you would normally get. And mind you, that this is where we are starting at. So if you want to do anything, there is an added time there as well. Resource change in a module, again, takes 28 seconds and normally takes 13 seconds. That's more than 50% of time savings. But change in a module, if you make the whole module change, you would typically not want to start it as a test because it's only for particular screens. It takes about 40 seconds, which is still better than doing a 2-minute build. But seriously, what are the advantages for you? It's much faster build times. Since you have smaller modules, they will keep growing, but it's still easy to spot issues with them because you have less files to look at, especially in your resource folders. Like if you have one big project, you have all the resources there. For Android Studio, at times, it gets even worse to even browse through those resources. And then you can also define your own SLAs, which are like service level agreements within the module about what is the threshold for the lint warnings you want, what is the threshold for the lint errors that you want, what is the unit test coverage you want to have, and what is the UI test coverage you want to have. So if you get a new module, you can start doing that. And at the end, what happens is this new module starts at a very high threshold, so you can keep maintaining it. And as you start pulling out pieces from other modules, you can keep on refactoring your code because you already have tests there. And how can you do it? So do some modularization, have fake or real data to inject in your app, And then you can create an app star test. It is nothing but an instrumentation test. So that's why I did not share any such snippet, because it's plain instrumentation test that just starts on either a device or an emulator. And then you just ask it to sleep. And then make the test depending on the types of features you work on. Here's something that I'd like to point out we ran into, was that when we were doing modularization, we did not realize that as soon as we start creating new modules, there will be more R files that will be generated during the intermediate build steps. And this causes a very bad indexing loop on Android Studio. So at times, if you make a change or a build, the Android Studio starts indexing. And this is horrible, because even on the most powerful Macs with, let's say, 16 gigs of RAM, this indexing takes forever. And it can keep on happening over and over again. We still don't have a solution, like a good solution to mitigate this problem, but we are trying to fix this either by upgrading the hardware, or by filing bugs at the Google Tracker, or looking into other alternatives, how we can tell IntelliJ or Android Studio to just skip the indexing part of those R files that we don't need. But again, no solution right now works better. And we for sure know that this is going to go high exponentially. So more modules, more R files, and they're going to grow exponentially. That, I think, is about it from my end. And if you have any questions, you could just throw them at me.
Please, questions?
Yes. Yeah.
It needs some time to translate them for English.
No worries.
Hello. You said that you tested your app with Rail and mock data, yes?
Mm-hmm.
And how did you do that? Because I might suggest that Rail data was confident.
I did not get your question. When you say real data was what?
Confident.
I'm not sure if I got your question. Could you write it again?
Confidential, yes.
Confidential.
Yes.
Right. I mean, when you say real data, of course, real data is not the data of the customers, but real data is a response that you would receive from the server. So it could still be a debug thing, but it's coming from the server. And when I say mock data, you could mock it either using static JSON files or whatever. But real means it's coming through the client, an OKHTTP client, from the server. That's what real data is. Real data is not the data of a user or something like that.
Okay, thank you. Thank you for the talk. Can you say what is your stack, technology stack? Because 2 minutes is very fast build for big project.
Mm-hmm.
What is your stack, your libraries?
I mean, I'm not sure if I remember by heart my build.gradle, but it's
maybe a Dagger or
no, we don't use Dagger right now. We do our own dependency injection, and then we try to avoid as much libraries as we can, because again, we need to customize builds and stuff for that. And we recently upgraded the Gradle plugin as well. But other than that, I think we just use Java and Kotlin for tests. Kotlin is not there in production code yet, but I don't think there's anything specific in the stack that I can talk about here.
Okay, thank you.
Hi, thanks
Hi.
for presentation. Can you say, please, how big your code base now? How much code lines? Approximately, not exactly.
Okay, I think we would have to work together on this. So let's start by seeing the code base was so from what I remember, they started writing the code of Android application for Booking.com on 12th December 2010. Why I remember this is because it was my birthday. And I just tried to see what's the first commit in the project, and I found out that it was 12th December 2010. It's about 8 years now. You could imagine like how much stuff would there be. But I honestly don't know the number of lines of code for you, to be honest. But it's a lot.
And one question from me.
Yes.
How long the whole process of modularization took? What time for all this process?
Right. So this is a very subjective question because it depends on what you're trying to abstract out. So what we try to do first is just take the smallest thing, that let's say a fragment or an activity, and then what you would do is just pull it out into a module. What then happens is you see a lot of imports failing because this module does not have access to those things. Then you can look at if you already have these things available through core services or app services, so you're done. What you don't have is the stuff that you have to modularize. So now you take a step back, you pull all those dependencies into a module, so now your activity is ready to run. Similarly, if you have a fragment within that activity, you would first have to probably pull that fragment out, get its dependencies out, and then do that. We try to do it for the people who are most affected. So you would try to go down the funnel first. So people who have to go down the funnel and test their changes, we try to pull those things out. Or probably something that's like we know it's too simple or will not have a lot of dependencies, we try to pull that out first. But it's always very hard to give estimates because you don't really know which file uses which other file unless you actually pull it out and then Android Studio complains, I cannot find this import. So yeah, it is a process that we keep on evolving, and when you start doing modularization more and more, you would have experience, and then you know, okay, this thing would probably need this, so let me pull this out first, and then I'm going to do this. But for every screen that we had, the timelines varied a lot.
Hi.
Yeah.
So could you please repeat idea with delaying app start test by one day?
Yeah. So delaying. So that's the thing. So app start test is not actually an app start test. It's just the app start. What you do is you start the app from that activity that you want to test, not test, but like play with. And then what you do is once everything is ready, the UI is visible, you would tell the emulator or the device, whatever instrument you're using for that test, to sleep. So the test goes into the sleep mode, but you can still use the app, right? And once you're done with your stuff, you just kill the app so the test will die. So it's something like an emulation of a screen that is going on your device. So it's not really a test to do something, but it's a test to give you access to that screen independently. So imagine on the booking app, if you have 5 screens, search results, property, book process, you can directly start book process using the app start test. So you won't have to go through all the search, results, details, whatever. That's the idea of the test. Someone had a question at the back.
You mentioned the custom annotation processor. I wonder what for you are you using it? Only for custom DI or something else?
I mean, that's a personal question, but
Yes.
it's. I think we have it for our ORM. So we have an ORM that we had built in-house a while back, and then we did some annotation processing on that. And that's the custom annotation processor that we have, and not for anything else. And that was also one of the reasons that meddled with JRebel, because JRebel already had support in the enterprise version for Dagger and a lot of other annotation processors that were available, but they did not have anything for this because they did not have the source code for that. So we tried to talk back and forth with the devs if we could figure out a solution, but by then JRebel itself died.
Oh, thanks.
Yeah.
Okay, I think that's all, but if you will have questions maybe later, you can find Ishan in our discussion area.
Sure.
So thank you very much for
Thank
sharing
you.
your experience.